Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody from the future on YouTube. Welcome to this new lecture, Information from Retrieval. Today will be a bit special because this is going to be mostly an introduction and showing you the roadmap, what we are going to be doing during the semester. It's also an opportunity to introduce you to the TA team who is right here. And yes, give you mostly a historical perspective on things. And then next week, the serious things are going to start. So I like to start the lecture by taking a concrete everyday scenario where you're discussing with your friends, maybe over lunch, and you're suddenly wondering about something that pops up in the conversation, then you have something you're wondering, like, when was Einstein born? And then you can start discussing, trying to infer the question, like in the good old times. But then we have some luxury today for these kind of things. So I wanted to see what sort of things that you actually do, which is an opportunity to calibrate this clicker app. So you can either go to the browser to this address on your laptop, or you can download what's called the EDU app 3. That's an ETH clicker application from either Android, iOS, what you prefer. But the simplest one is to go to the browser. But of course, in the long term, if you have the app, it might be easier. So I give you a bit of time the first time to do this, but we'll regularly have questions like that during the semester. So here is the question. What do? Do you look it up on Wikipedia? Do you Google on your smartphone? Do you Google on your desktop? Do you look it up on YouTube? Do you ask a professor? Do you go to the library? Do you try to run a simulation? I'm giving you a bit of time to make sure that everybody can connect. So of course, you can do it from the lecture hall. You can do it from Zoom too. If you're online, you can also participate. This is all hybrid. Seems to be stabilizing. All right, there is actually a big majority. Oh, some people like to simulate the universe, but there is a majority. 4/5 of you like to Google on your smartphone, and indeed, this is what we have in 2023. We have the internet on our hands, and in fact, this is the biggest information retrieval system that we can imagine, right? All right, let me go back to the slides. And normally, if I did it correctly, we should land exactly where we were. So indeed, you grab your smartphone. I kind of expected this answer. And you start entering your query in Google, and then a lot of things start happening. So first, nowadays, it didn't used to be the case, but now you directly get an answer like this. So it turns out to be March 14th, 1879. It was long ago. Then you get a lot of context that gets triggered by the engine. You get some meta information with probably a link to Wikipedia, and then you even start getting the related searches, and people also search for, which is also machine learning based with clusters and so on, right? So there's a lot of things you can do with a search engine, and actually it even went beyond just looking up stuff, because some people use it as a calculator. Does anybody here ever use Google as a calculator? Some of you, right? All right. And then, of course, that gives you the results, but as you can imagine, gives you a full calculator right here on your screen, and it even starts searching for plenty of other related things, right? So that triggers a lot of things. But we are in 2023, and in fact, something happens that I couldn't show last year, but now we have a new way of doing things. We can ask a generative AI. So I tried. This is real, and you can even start a whole conversation with the AI, as you can see. And this is in a way fulfilling a similar purpose, in essence, because you look for information. and it gives it back to you, right? Of course, there's limitations, right? The AI can this is known as hallucination, right? So you have to be very careful on the information you get. But the same is true for the internet, right? When you search on the web, you can also land on websites that don't have accurate content. So, right, it requires critical thinking. You have to double check, you know, the answers you get. It also works as a calculator, by the way. Okay. But before that, before we had the luxury of generative AI, and it's still in its infancy and probably also not very mature yet, we had search engines. So that was 2022, right? So you go there, you type search, can also be Bing, Yahoo, DuckDuckGo. There's plenty of search engines like that. But it actually evolved. Well, actually didn't evolve that much. I mean, the front end didn't really change that much. The logo evolved, and that was 1998, where this kind of search engine started becoming mainstream. But actually, so these were the two people, you probably know them by now, Larry Page and Sergey Brin, who co-founded the company. Back then, they were at Stanford doing their PhD, also got a few professors back then involved to help out. But basically, they thought, okay, we're going to download the entire internet, and we're going to index the entire internet. In essence, an information retrieval system. This is even earlier. So this was one when it was hosted at Stanford, and back then, not many people were using it, right? Now, I don't know, I mean, the years pass. Whoever saw this, whoever heard about Alta Vista? Some people, okay, because this is getting old, right? But before Google, we had search engines already, and Alta Vista was the dominating search engine at the time. You can see that the screen was a bit more overloaded. It didn't have the fancy design with just the logo, the text box, then search, and I'm lucky. But in fact, when Google appeared, a lot of search engines created some spin-off of their page that looked just like Google with just the logo and so on. So it had an influence. But back then, it was not just a search engine. It was also a news portal with everything that was going on. You can see that the browsers also looked slightly different. In fact, that was Netscape Navigator. Who heard of Netscape Navigator? Some of you as well. So back then, that was before. Then there was Internet Explorer, and then there was Chrome that dominated. So yes, this is history, and this is how things evolve. And now this looks more and more like in an antiquity, in an antique store. These things. Anyway, there was another one back then that's called Yahoo. Yahoo was a bit of a search engine, but it was mostly organized as a directory, as an attempt to catalog the web and classify the web pages. The web was also smaller back then. And so people were trying to just create categories and subcategories and organize the web in this way. And then you would see all of the front pages of the websites that you were looking for, right? So Yahoo was also one of the big players back then. But guess what? There was something before the web, and there was something before we had search engines that give you instant results. Encarta, has anybody heard about that one? Some of you as well. So this was when you downloaded the entire encyclopedia onto your machine. When actually you didn't even download it, you went to a store and you actually purchased a DVD or a set of CDs, and then you would directly read it from your computer, right? But you basically had an offline access to an encyclopedia. So of course there was still a front end with some user interface, and you could also run searches on that, but it wasn't on the internet, it wasn't on the web, it was just local on your computer. But if you think of it, that was kind of a similar purpose, right? So that was actually pretty popular for when you had a presentation to do at school in front of the class, then this is what students would use for their research. And before that, we didn't have computers, so we had books. And this is something that actually dates back to the 18th century. It was an attempt to have some repository of knowledge, but compressed, about a high-level summary of the knowledge of humankind. And this was done in the form of encyclopedias. So an encyclopedia, who never saw that? I'm sure you saw encyclopedias. Okay, most of you. So this was organized in plenty of volumes like that. But what was particular about them, because how do you search information? So first, you could use the alphabetical order, because many of them actually still contain an alphabetically sorted list of keywords. But typically at the end, and this is probably this one right here, I guess, either this one or this one, there can be multiple purposes to the ones that come at the end. But basically, you had a whole book with, again, an alphabetical list of keywords. And you would look up the keywords you're looking for, and it would point you to the volume and to the page to look at. And then you would go and pick up the other volumes that you're interested in, right? So Britannica is one of them. There was also Encyclopedia Universalis and so on. So there was a couple of famous brands. But basically, it all dates back. So in that case, 1768. So that was 2 centuries ago, almost now, well, maybe 2.5 centuries ago. Okay, and that was the time pre-computers. But actually, it's even older than that, because if you go all the way back now, it's thousands of years to the antiquity, there was already libraries. And these were efforts to accumulate knowledge at the same place. So in that case, it was in ancient Egypt. But interestingly, that was triggered and influenced a lot by the ancient Greeks. Because there was a lot of Greek scholars who traveled to Egypt, like Plato and some others, and who were exploring and exchanging and so on. And so this library, the Library of Alexandria, was founded. What's interesting is that as a consequence, the first language of the books in that library was Greek, and not Egyptian. I don't know if back then it was maybe a different language than Arabic, but the Greek was basically the first language to appear in that library. And so there was a few interesting stories because back then this is where there was Alexander the Great, and you know, people were traveling in ships, exploring the world, and so they were explicitly asked by the kings or the people in charge to document what they see and bring back knowledge. And all of that knowledge was then accumulated in places like that. In that case, the library, that was Ptolemy's the first and the second, and they were even given instructions when there were incoming ships coming from other parts of the world docking in the harbor. They would send soldiers or people to basically search the ship for books. And they would bring back the books to the library and look if there's anything of interest in the books. If there is, they would make a copy of the book, keep it, and bring back a copy to the ship. And they would keep it in the library. So you see, this was really something that already thousands of years ago, the gathering and accumulation of knowledge was very important. Okay, so that's the Library of Alexandria. I think also there's a popular belief that it burns down, but actually it didn't really burn down. It's more that it faded over time as centuries passed. Okay, another example is the Vatican Library, which the modern version dates back to 1475, but there's plenty of artifacts that date back to even earlier than that. What's interesting here is that there is a word that maybe you haven't heard. It's codices, codex, codices. So what is this? This is in fact the early version of a book. It's this idea that you were taking the pieces of paper and putting them together and in some thick volume. So that was called the codex. Codices, the plural form. And then, of course, as time elapsed, they became bigger and bigger and bigger. So this is the Herzog August Bibliothek in Germany. It's the 17th century. We are here in the 6-digit number of books. There's the British Museum, which is also dating back in that case to the 19th century, 1845. And now in modern times, so the Library of Congress, it's quite recent, actually, 1990. We are here in the 9 digits number of documents. So documents can not just be books, right? It's also video, audio, music sheets, maps, and so on and so on. So if we look now today, what the largest such repositories are, so the second largest is in Shanghai, in China. So this is a picture. And the largest today is the British Library. that you see here. And I think we are here at 170 million documents in these at these places. Right. And of course, when you start harvesting and hoarding knowledge like that, you have to make it searchable. So we didn't start searching or building systems to search for knowledge just when we had computers. Back then already it started. And we needed to find a way to index, this was already called an index, to index all the books that we have in the library. And the popular scheme that is recent, I mean, if you compare it to the antiquity, it's relatively recent, but this is the decimal classification of Dewey, the Dewey Decimal System. Almost any library in the world follows that system in order to index books. So of course, now when you look for a book, you go to the website of the ETH library, and then there's these little robots that bring to the desk, and then you get them, right? But back then, at least when I was in school, we had this classification. So this is what you see on the shelves, but there was basically a map like this, a big poster somewhere in the library, and you would try to look for for the topic that you want. So you see how this is all classified. And in fact, Yahoo, the search engine, kind of follows this similar approach of classification, right? So this is called the Dewey Decimal System. It starts with the hundreds and then the tens for subcategories and so on and so on and so on, right? Okay. And there's other efforts like the Verschlagwortung in German to try to organize the knowledge. There's also the notion of thesaurus, try to find synonyms, antonyms. So when you are looking for specific keywords, right? So you see, there's been a lot of research and efforts, even pre-computers. That's the main thing to remember. Pre-computers, we already started to make information retrievable. This is a picture that dates back to the 1940s by Vannevar Bush, which is an effort to imagine some device that would be hidden below your desk that gives you some front end with which we can retrieve information. In the essence, that was a very early version of a computer or even of a tablet device, of course, a little bit bigger, right? But the system would give you all of the information you need. So this is Vannevar Bush who imagined that. And in fact, for the time, that was really visionary from the 1940s to already envision something like that. So of course, you didn't have transistors and so on back then, but it was mostly mechanical in the thinking. All right, I think I have another question for you. Yes, I wanted to see your main background. I assume most of you are computer science students from the bachelor's, but sometimes we also have a few visitors from other departments. Or do we? Oh, everybody's a computer scientist. Oh, 98%. Oh, we have somebody studying geomatics and environmental sciences. Okay, but that gives me a good impression. All right, so to give you a bit of history, information retrieval used to be a master's level course back then, so it was more advanced. And then we decided to convert it to a bachelor's level course because first there was not a lot of courses in the third year of the bachelor's in the catalog, and there was a demand for that. So when I took it over, I converted it to a bachelor's level course for specifically tailored for you at the bachelor's level. All right. I think I had another. I can use the opportunity to also ask you this. I will come back to the details later. Just to feel your knowledge of Python. Of course, Python is just a language, right? In the worst case, you can learn it and so on, but it just gives me a general idea. We're going to be using Jupyter notebooks and all right, so most of you are familiar with it. A few of you will take this as an opportunity to learn it a bit. Okay. All right. But your computer scientist learning new languages is really something something easy. Once you have learned a language, you will see they all look the same. Okay. Let me then try to land exactly where we left. With a bit of luck, we'll be exactly there. Yes. So now I'd like to give you another historical perspective, but this time not focused on libraries and knowledge repositories, but focused on databases. So I like to start with database prehistory. What does it mean, prehistory? Well, it's before a certain date. So of course, in the case of prehistory history, in the classical sense, we use the invention of writing. But for databases, we'll see it's more like 1970. In very ancient times, it's even earlier than the Library of Alexandria, we didn't even have the luxury of books. So the only way that knowledge was transmitted was by speaking and singing. So this is how every generation would just pass over the information to the next one, and people try to remember things. So everything was basically stored here. But as you can imagine, this could be distorted. That caused problems because you can lose information. Information can be changed, can be altered. So this is not very reliable. However, then came the invention of writing. This is the Rosetta Stone, I think, with the same thing in 3 languages that allowed Champollion to translate the Egyptian hieroglyphs. The invention of writing changed a lot of things because suddenly we could, over longer periods of time, keep track of information without just relying on our brains. And the proof that it works is that we have it today. We do have access to these documents that were put on clay tablets today. Of course, not everything, but some of that has remained. So, as a consequence, we do have access to some of what was spoken and sung back then, because that was then put in writing. So we have the earliest works that we have. For example, in Europe, we have the Odyssey, the Iliad, in the Indian subcontinent, the Mahabharata, and so on and so on. So we have plenty of epics, of very, very, very large books that keeps track of what was told. So we still have access to it today, but this is thanks to writing. So these were clay tablets, cuneiform writing, meaning that you just you warmed it up and then you use the hammer in order to make holes in it. Well, not holes, but traces in it, and then you cool it down, and then this stays. And this is where the writing comes from. But you had 2 types of tablets. The first type was text, linear. You just tell stories and about kings or about whoever was in charge back then for the posterity. But the other type is actually tabular. And that's just like relational databases, which is actually amazing because relational tables actually already existed thousands of years ago. And that actually gives me the goosebumps every time because it almost feels like you're holding some tablet with a spreadsheet software on it, but no, that's thousands of years old. So in that case, that's the right triangle sizes that are integers like 3, 4, 5, and so on. Actually more elaborate than just 3, 4, 5. These were actually already quite impressive to know back then. But yes, people structured data already as tables. Then came printing. So printing was the ability to copy things over. So you no longer needed the monks who were copying the books one by one. So for example, imagine in Alexandria, when they were copying the books that they took from the ships, they needed to do it manually, book by book. So that was pretty resource consuming. But with the printing press, you could just amplify everything and make millions and millions of copies. And this is also what led to the golden age of newspapers in the 19th century. And then things accelerated with computers and things getting smaller with the transistor. We just kept doing the same things, but faster and faster and faster. This actually consumed almost the electricity of an entire city, actually cutting down the electricity from half of the city when you switched it on. But actually, this is probably orders of magnitude less powerful than the smartphone you have in your hands. So this is just a comparison of how things have evolved. But back then, if you go way back to the 60s, everything was stored as files in files and directories on disks, and that was very cumbersome. And thus came history with Edgar code. because he suggested that we shouldn't be looking at files and directories. We should instead be looking at an abstract version, so a table, for example, and this is how relational databases were invented. But in fact, as I said, once you saw the clay tablets with the same structure, you realize the idea of the table is actually very old. In the 80s, that was object-oriented programming, like C++, and then Java came 10 years later. So this was the object era, where people tried to connect databases with object-oriented languages. Then in the 2000s, the NoSQL era with graphs, with triple stores, key value stores, column stores, document stores, and so on. Right. So what happened, and actually that goes also along with how libraries became bigger and bigger and bigger, is that we have these absolutely enormous quantities of data to deal with, and that is often summarized with the 3 V's: volume, variety, velocity. So the first assignment that you have to do is to learn these by heart. These are all the prefixes. Who already knew them? Not all of you. Maybe these two, not everybody knew, because these are actually new. This is just a few months old. This is Rona and Quetta. But before that, we have all the others. So it's very important that you know them. This is standardized. This is international, and everybody focuses on them. How do I remember them? Well, actually, if you know the roots of Greek numbers, look, for example, at tera. That's close to tetra in Greek. Right? You confirm, Panos? In Greek, tetra. Oh, the modern Greek. Yeah, that's ancient Greek. So in ancient Greek, it was tetra. So tetra, and look at the number of zeros. 1, 2, 3, 4. The groups of 3 zeros, 4 times tetra. Penta, that would be 5. Close to peta, 5 groups. Hexa, close to hexa. Then zeta, close to hepta. So this was all meant with this in mind. And even the last one, Rona, that's close to nonna, which is 9, and queta, I don't even know how it is for 10, but it's also close to the Greek, the ancient Greek version of 10. Anyway, these are the scales. And also in this lecture, we are going to go a little bit to large scales for indexing information. Okay, so that's the volume. Then the variety, you need to know by heart that there are 5 fundamental shapes of data: tables, trees, graphs, cubes, and unstructured. And in fact, in this lecture, we are going to be interested in unstructured data, right? So 5 fundamental shapes of data. It is super important, because if you don't understand that, then your system will be slow. If you pay attention to the shape of your data and select the appropriate storage format and query language and so on, then things are going to be faster. But in this lecture, we will focus just on unstructured data. All right, so I did say unstructured data. Actually, it's a spectrum. There it goes all the way from unstructured to structured. So the structured, highly structured, that's what typically people think of a relational table when they say that. Cubes could also be considered even more structured than the table. This is useful for business analytics. Trees are denormalized versions of tables. This is something we cover in the big data lecture if you want to come back next fall or next year. Graph databases, a bit less structured. And then we have text like this. So this is a whole spectrum of structure. So of course, I'm going to dive more into unstructured data and not the rest, because this is a different story. But look, if you look at the evolution of things, you can see that the amount of unstructured data actually grew much faster than the amount of structured data. And in fact, in the 1970s, back then, we didn't produce that much data. We kind of had control over the data we create. And so, of course, most of it was structured. You would put it in spreadsheets or in tables, because you already had in mind what to do with it. The problem is that now we just create data every day, we accumulate it, but it's become a byproduct. So this is why there's a huge amount of unstructured data. So all the techniques that we have for indexing structured or semi-structured data with SQL and relational databases and so on just doesn't work anymore. You cannot use it on text or images or videos. That just doesn't work. So you need other kinds of techniques. Yeah, we have to find ways to deal with that. Of course, I'm not going to tell you today, because this is what we'll spend the semester on, but there are ways that you can actually do things and index things and even invent query languages for querying data in structured data. All right, another kind of unstructured data, even though it's less of a focus for this course, is the concept of image, right, or bitmap. So bitmap is really when you store pixel by pixel. Of course, today it's compressed, so we use Fourier transform and so that sort of things to store it differently. But if you think of a bitmap, this is really the raw format pixel by pixel. For machine learning, actually, it kind of makes sense when you want to analyze an image in clusters and so on. It makes sense to actually see the actual pixels. What I put on the bottom right here is the first photography ever. In fact, photography was discovered by accident. It's just somebody, his name slipped my mind, but who left some plates unattended and then came back and realized that it had actually imprinted some pattern on another layer. And so this is how photography was discovered. And this was the first attempt to actually take a photograph. So of course, you don't really see as much as you would on your 4K television, but you still can distinguish some houses and landscape and the sky and so on, right? So it was a revolution at the time. Then we have audio, we have music. This is also unstructured. This is also something we compress. So for example, there was even a period where MP3 was a buzzword because we were downloading music libraries to our iPods or small devices. Of course, now it's no longer necessary because we just stream from the internet, but this is another kind of unstructured data. Tweets could be considered unstructured data in the sense that it's text, even though there is some structure in the collection of tweets that you can still extract as JSON, right? But this is another example of what you want to analyze. And in fact, the Library of Congress, they gave up now, but at some point, they tried to archive all tweets and keep them in their repository in the Library of Congress. But then there were so many that they just gave up, and they said, okay, we stop maintaining a copy of all the tweets. But this is also a repository of knowledge, because even if you think of archaeology, people in 1,000 years, they want to see what people were actually doing back then in the in the third millennium. Okay. Then we have videos, but videos, I mean, strictly speaking, is just a sequence of bitmaps where you could add some sound, but here again, you can compress things. This is an old one where, well, that's a famous one where you can imagine what happens next that has to do with, I think, water. All right, but unstructured data is in a very raw form. This is what makes it challenging. It's not as clear as for tables how you deal with it, because this is also language. So it's a very raw form. It doesn't have any explicit patterns. It's all implicit, because text, if you look at it, it's just a bunch of characters. So of course, there are linguists that analyze that with lexemes and so on, but it's all implicit, right? The grammar of a language, the pixels, the waves, if you analyze with Fourier transforms and so on. So here the problem that we have is called the semantic gap, because there is a big gap between the representation of information, which is the way we store it, for example, as a sequence of characters in text, and the semantic description of the information. How do you extract meaning? And in fact, for a language, it's very difficult, because if you don't know the language, you don't know the vocabulary, you don't know how the words map to concepts, you don't know the grammar of the language, we'll do a bit of linguistic in a few weeks, it's challenging. And in fact, it is so challenging that some of the clay tablets that we found, we are not even able to decrypt them. We have no idea what there is on them, even today. So this is because of that gap that is also causing some challenge. So the pipeline, the natural pipeline, as it is in general, and that's across all shapes, is that you want to extract meaning from the data, turn it into information, because again, a clay tablet, when you don't understand what there is on it, it's just data, but you don't have any information. You can turn it into information and then into knowledge with a meaningful application. And then the next step is wisdom, when you use all of that, hopefully wisely. So this takes care of the variety. That was the second V, right? And the third V is volume. So the third V is about the fact that we keep producing this in larger and larger volumes. So today, as I said, the web is an example of knowledge repository, but it's gigantic. It's the entire planet. The scale of that is just unprecedented. You access it with your computers, but it's spread all over the world, the actual knowledge. So you have, of course, plenty of places on the web that index knowledge. You have, for example, repositories. So in that case, it's financial data on Bloomberg. You have also scientific papers and articles that are kept and nicely indexed. Archive.org, for example, is one that is maintained by Cornell University. And that is also growing and growing and growing. I mean, back then, per month, you needed 4 digits to identify a paper, and now it's 5. So it keeps evolving in order to account for all the growth in there. And by the way, here you see again all these categories. It's always the same idea as the Dewey classification. Of course, here it's restricted to specific fields, but it's similar to Yahoo, to the Dewey classification. Okay, then there are repositories of things to buy, right? All of these shops. So here is Amazon, but I could also cite in Switzerland, Digitech, Galaxus, and so on and so on. So these are also repositories, and you need to index things in order to make it to find them. There are also all these social media. So there was Twitter, Instagram, and so on. So these are all places where you basically hoard knowledge or information. But in order to understand the challenge with dealing with this growth and the way that it keeps getting bigger and bigger and bigger, you really have to understand the, how can I put it, that things got out of hands and that we are in big trouble. In order to explain that, this is something I also say in the introduction of the big data lecture, but as we will see, it is also relevant to this lecture because we will see elements of big data in this course as well. There are 3 paramount factors that evolved: capacity, throughput, and latency. People can use different words, so I will tell you what I mean with these 3 words, right? So capacity is how much data can we store. It's a quantity of data, for example, the capacity of a hard drive or of a book. Throughput is how fast you can read or transmit data. So it's bytes per second, right? And latency is a time, it's a duration, it's how much time do you need to wait until you start receiving data. Some people use latency for until you stop receiving data, but in the context of big data and large scales, I prefer to use it in the context of until you start receiving data, because this is kind of a waste of time. Like there is nothing transmitted in that time. So capacity, throughput, and latency. And now, if we want to understand how these 3 have evolved through time, we need to take a time machine again and look back to the first commercially available hard drive. That was the IBM Ramac 350. That was back in 1956. It has an incredible 5 megabytes capacity. For the time, that was very impressive. You could read 12.5 kilobytes per second. In fact, they used the word character back then, so it was more like 12,500 characters per second. The latency was 600 milliseconds. Why? Because they are rotating parts. So you need to wait until, that rotates all the way to the place where you read things. So this is where the latency comes from in these mechanical drives. Of course, in flash drives today, you no longer have these mechanical components, but there is still a latency. What you need to be aware of is that the dimension of that is enormous. This is the sort of dimension we are talking about. Right. So this is like 1.70 meters, 1.50 meters. This was absolutely gigantic just to store 5 megabytes. And today, what do we have? Well, we have that. So I need to zoom in a bit. So we can store hard drives up to 26 terabytes. That's I think the largest one. And 30 terabytes is on the way, as I heard. And the next goal is to go to 50 terabytes. The throughput is 250 megabytes per second. The latency, it's less, 4 milliseconds. Of course, the lower, the better. And the dimensions, well, this is more like this, right? You know how a hard drive looks like, but this is basically this. Is there another microphone? Could it be another microphone that is, yeah, okay. Maybe, or the catch box? Okay. Let me see, maybe I forgot to, no, everybody is muted. All right, maybe it's just an artifact of the room. Sometimes there's just technical glitches. Or maybe it's just me breathing. That could also just be me. All right, anyway. All right, so you see the evolution of that. What if we plot it? What did I want to ask here? No, I think that's what I didn't have plans. Okay, what if we plot it? So the progress we made is that the capacity that we store per unit of volume, because you have to consider that it's smaller, increased by that much. The throughput, it's already there, increased by that much. And latency, you don't even see it. In fact, the factors are roughly 200 billion, just the order of magnitude of the increase of capacity, but throughput, 20K in comparison. And latency, the order of magnitude is 150x. So even on a logarithmic scale, it's showing how I hope you see that we are in big trouble, because we accumulate data at super huge scales, but we cannot even read it fast enough to deal with it, right? And in fact, this is something that the same person who invented the MEMX, Vannevar Bush, already envisioned back then, that this would happen. And knowing that this was said in the 1940s, this is actually pretty amazing to already anticipate on this, right? So just to show you and give you an impression, let's not use a hard drive, let's use a book. So the capacity would be 600,000 words. The throughput would be, let's say, you read 1,000 words per minute. And the latency, but it's just for the purpose of illustration, is when you stand up, go to the shelf and pick the book, right? This is how it works in libraries. And if you do the analogy with a book and do the division, then it will take 10 hours to read a book. That sounds pretty reasonable for today, right? But now, imagine that we go 2 centuries into the future, and the capacity of a book has increased by the same factor as for hard drives since 1956, 200 billion, but the speed at which you read the book has only increased by 20K. Now you need 11,400 years to finish the book. This is how in big trouble we are. How do we solve that? Well, we need to find tricks, and the trick is actually to parallelize, and we'll do some of that too in this lecture. Because then if you distribute it to people all over the planet, let's say 200 million people, then you can again read it all in 10 hours, right? It works again. And in fact, this is why we have all of these this infrastructure in data centers with parallel computers, right? So in a few weeks, we'll go into this and see how we can actually build indices using plenty of machines like that. And the other aspect is batch processing. This is also something we'll see a little bit in this course. All right. Okay, so this is the scope of the lecture. We are going to look at data, information, knowledge, wisdom, but actually more focusing on the data part, unstructured data. So it's mostly going to be a database lecture. There is no machine learning. Machine learning is actually very closely related to information retrieval. I mean, with generative AI, it's probably something that sounds intuitive, but we focus on databases and querying data. No machine learning at all. There are other lectures at ETH about machine learning. I'm thinking of Andreas Krause, Carlos Cotrini. So there are lectures that teach all of that. The book that we will be using during the lecture, in fact, half of the book is machine learning, right? And of course, we are not doing that. This is what's done in the other lectures, but half of the book is not machine learning, and that's the part that we are going to be focusing on. So I'm going to finish this first hour before the break, introducing the team who is right here. So we have Abhishek, who is the head TA and who will moderate the lecture. So Abhishek is here in the lecture also to make sure that when there are raised hands and when people write questions on Zoom, then Abhishek interrupts me and we can discuss, right? So you can ask questions whether you are in the lecture hall or whether you are on Zoom, and Abhishek will make sure that I answer. Unfortunately, it doesn't work with YouTube. We cannot send the questions back in time, and you can just use the chat platform or another channel if you're watching us from YouTube. Okay, then we have Marco right next to Abhishek. We have Panos right here, Chanshin, and you? No, and Christopher, I know he didn't come either. All right, so this is the whole team. And I'm going to end here for the first hour, right? We actually are making good progress today, so we might even be finishing early. We'll see. But anyway, you get 15 minutes of breaks, so we will continue at 11:15 and take it from there. Thank you very much.